Hey, my name is Ben Hutton, and you're joining us for JSON Schema in Production, where we talk to individuals working with JSON Schema in real life situations. So today we have with us Suresh Srinivas. Thank you so much for joining us today. Why don't you introduce yourself and tell us a bit about who you are and what you do?
Hi, Ben. Thank you for having me. My name is Suresh Srinivas. I have been in the data space for a long time, and data space, schema is the most important thing, right, for the data. Just to give you a background, I was part of the core team that built Hadoop, a project that started the big data revolution, right? So we built it at Yahoo, and Hadoop started getting a lot of traction. And then big data, the word became a thing. And so we started, I was one of the co-founders of a company that was built around Hadoop as open source, commercializing it, pure open source approach called Hortonworks. And, Hortonworks was a very successful company. And the big data revolution, digital transformation, all of those things are making data an important aspect of every company, right? So, however, right, so we had built Hadoop, we had built scalable storage, scalable compute, all of that. So users had these powerful tools at their fingertips, but still getting data right, getting data outcomes easily, efficiently, in a productive manner, in a reliable manner was a big challenge. So towards the later part of my Hortonworks journey, I became more interested in how can we make data usable? How can we improve data experience? How can we improve data productivity, reliability? And so I decided to join Uber as a chief architect for data there, to see the user side of platforms that we had built, right? So it's just, completing the picture of, data for me in my mind. And through that, there were a lot of improvements that we did for data at Uber, and there were a lot of lessons and insights learned. And the things that we did at Uber is required in the outside world. So we are building a project called OpenMetadata, a project which essentially collects all the data knowledge, data context, which we call as metadata, in a centralized manner, so that you can do a lot of things, right? You can discover the data that you have within your organization. You can understand it. You can actually do governance. Governance is a key piece of, any company that is collecting data. And then, there are a few things that we are doing differently. Data is used by distributed teams, right? That don't know each other, that are not able to collaborate and connect with each other. So there is a silo of people. So one of the things that we are trying to do is build effective collaboration around data using metadata, right? So, and then there are many innovations that are possible around metadata. Today, metadata is not done well. It is not tapped to its fullest potential. We want to change that. So, Open Metadata is the project. We hope it provides a metadata store and APIs that will transform the world of data.
Yeah, I can definitely see how metadata is important. I definitely understand the silo problem. I've worked on a number of projects where there are data silos and not within the same organizations, where sometimes and if you need to be able to inspect or exchange that data, particularly across international borders, that can be a real problem.
Yep. There are so many regulations. There are so many, all the way from developers and the users of data and the regulation and regulatory compliance. And then, the transformation that is happening in the data world, the AI, ML, all of those things. It's an interesting time and space to be in.
Just as you were talking, it kind of reminded me of the FAIR data principle. I don't know if you've heard of it. I believe it came from the sort of science side of things, where researchers often have their own little bit of data, and it's kept private or not very accessible. And the FAIR principles stand for findable, accessible, interoperable, and reusable. And it kind of sounds like you're trying to do that for companies internally to do with their metadata. Because when you don't have those principles in place, it makes using that data actually very difficult.
Actually, I'm going to use that explanation. That's perfect. Actually, it summarizes what we are trying to do with OpenMetadata.
Mm-hmm. So tell me a little bit more about when you were at Uber. What sort of challenges were you discovering? What sort of problems were you running up against in terms of metadata?
Yeah, so even before going to metadata, I'll actually talk about why schemas are important. And this has nothing to do with metadata. It is actually related to data, right? So at Uber, when I joined, a lot of people would say our data is hard to use. And I decided to dig deeper into why that is the case. And at Uber, we had 3,000 microservices, a lot of microservices. Mm-hmm. And essentially every microservice has an API, and it has some data that is storing in the transactional databases, online databases. And when I actually did just a study of what the schemas are for these 3,000 different microservices, some of the core types like location, which is core for Uber,
mm-hmm.
Point, currency amount, exchange rate, different microservices had defined their own schemas. Okay, so somebody called a point a location, somebody called location a point, somebody had location with 8 fields, somebody had location with 3 fields. Now imagine, so it's sort of like people are using the same word, but they mean different things, and these words are spelled differently. And now you have this large organization that is trying to actually communicate with each other, and those words mean different things depending on where it is coming from, has different spelling. So essentially it is gibberish, right? That conversation has become gibberish. Mm-hmm. And imagine all the data that is coming from these online microservices, it gets fed into these offline systems like data warehouses and data lakes in the world of data for offline analytics. Now, essentially, you need to say this microservice, it is sending location, it actually means this, right? So you need to have this translation for all these dialects that are completely inconsistent with each other.
Yeah.
And so what the first thing that we did was we did some data standardization. Mm-hmm. That is, define the core types and abstractions that are required for describing what Uber is and what are the core entities are. How do you build those core entities? What types are required for building those, right? And those types are reusable and all of that. And that we ended up doing, building our own tool. So we had this data modeling language that we built on our own. We had a conversion tool, and in the big data world, there are different schemas, right? So there are JSON schemas, there are arrow schemas that are used, especially for events. Many of the microservices are built using this Thrift and Protobuf. Mm-hmm. So there are many different schemas, and imagine the problem of trying to standardize these types across these different, schema languages. So we ended up building this tool where we would actually have another schema language to model all these core types. And then we built a tool that translates and, produces schema bindings in different languages like Thrift, Protobuf, Avro, and all of that. And that, as we started adopting that core vocabulary, the type system that we built, the standardized types, then data became easier to consume, right? So, so that is what we had done. Now, when I started building OpenMetadata, now OpenMetadata is capturing metadata about data. So it's data about data, right? And core reason why it is hard to use data is, one is inconsistency in vocabulary, right? Second is schemas. You should actually, if the schemas are not well designed, data becomes a lot harder to consume. You have to do a lot more work to make it consumable for yourself. And then if the schemas are not documented, right, and the constraints and all the documentation is not there, people are not able to understand the data. The worst is people misunderstand the data and misuse the data, resulting in bugs, right? And finally, right, in order to build those schemas, you need to have this vocabulary, right, reusable types and all of those things, without which you're essentially, using types like string and things like that instead of having strongly typed reusable types, right? So and so I was actually at that point in time, thinking of building my own tool. And then I bumped into JSON schema because JSON is the language of the internet. And, that language must have grammar, must have rules. And that grammar and rules is coming from JSON schema. And I was actually blown away by, what JSON schema had. And we would never have built this custom tool at Uber if I had bumped into JSON schema. So, JSON schema has been an awesome building block, a foundational building block for our project, where we are building metadata standards. And in order to model the metadata and whole bunch of other things, JSON schema is the foundational building block.
Yeah, definitely. I mean, when you were starting to build OpenMetadata, did you consider any other schema formats like you were talking about, Avro and Thrift? I mean, they're often compared, but did you sort of seriously consider them and weigh them up versus JSON schema?
Yeah, I have actually, at the time when I was, when we made the choice of JSON schema, I had more experience with Protobuf and Avro. Okay. But I think the emphasis there is to reduce the payload size, performance, things like that. With JSON schema, it is actually human consumable, right? JSON is well understood. JSON schema is nothing but JSON, right? So JSON schema is easy to understand for human beings, for documentation, and for machine consumption, right? And then the second thing is building APIs was very important for us. And you can build APIs in Thrift and have Protobuf and all of that. But REST APIs are the dominant form of APIs that are used by everybody, and REST APIs are based on JSON. And so for us, our API specification itself is through JSON schema. So because we were so focused on APIs and schema modeling, and the rich tool set and the capability and features that JSON schema had, we chose JSON schema. And I'll also, go over as we talk. I was pleasantly surprised by many things that we did not expect that we got. That's been, amazing for our project.
Yeah, I mean, yeah, definitely. Like the other schemas that you mentioned are definitely more for compressed data and over the wire formats, and have a lot more sort of constraints around how you have to use them in order to actually make use of them. And I guess they're more used in internal APIs where you have complete control over that ecosystem, like Uber, where you have control over those microservices. But for the situation where you're expecting other consumers to use your APIs, you can use those protocols. But if you want to really enable your users and lower that barrier to entry, JSON schema is a nice optional addition to make that REST API, JSON-based API, really easy to consume and easy to understand.
Yep, and debugging, human readability, all of those things are super important.
Yeah, I know a lot of people still like XML for doing these sort of things and XML schema, but I still find JSON just so much more human readable. People complain about the verbosity compared to other more terse schema languages, particularly more recently a schema language called Q, which is more of a data definition language, I guess. It's very concise, and that has its benefits, but actually, verbosity and human readability, is okay. I started to believe that longer variable names rather than shorter variable names are actually more beneficial because the primary consumer is going to be a human, right?
Correct. Especially in our case, right? This is APIs, human consumable APIs. So, you have trade-offs, right? Performance, QPS, you're optimizing for that. That is not our primary concern. Human readability and understandability is important. So, an obfuscation or, something that requires a long learning curve to understand what that schema is and how it is organized and all of that versus something that is easy to understand. Just, people get the idea the first time they look at it. That is important for us. So.
Yeah, definitely. I can understand that. Particularly when you're looking to, bring it's really about bringing people together. And as you were saying earlier, it's the people problem that's always the hardest to solve. Talk to me more about open metadata and we talked about the project and how you started it, but what's your sort of aim? What's the objective of open metadata as a project now?
Yeah, so let me just give you an idea of what has happened in the data landscape and how tool sets have evolved and what are the problems with it. Clearly, last decade of digital transformation, right? Everybody has an online presence. They are looking at user behavior. They are running experimentation, AI, ML. A lot of this digital transformation has resulted in huge volumes of data, right? And then what has happened is there are billions of dollars that got invested both in open source and in non-open source companies to build data platforms, right, where you can actually store this data, process this data, use various kinds of algorithms, right, starting from analytics all the way to machine learning. That platforms and services are maturing right now. And now the other thing that has happened right around the people aspect of data is if you look at 10, 15 years ago, most companies would have 2 or 3 people. The company has very, small amount of data. So these 2, 3 people understand all the, data really well, the gotchas and all of that. And then they would produce these reports or dashboards that is consumed by 1 or 2 people, 3 people, maybe a CEO in the company. That is how the world was. But right now, the volume of data is so much, the amount of data is so much. Second thing, many people are want to be data driven, right? Every part of the organization wants to be data driven, access data, make data to, make decisions, right? Use data to make decisions. And so, there are more people using the data, and there is more distributed teams that are actually producing and curating and making data available. And then, there's a whole bunch of data consumers, right, across the organization. So, teams have become distributed. There are more people now. Now, if you sort of look at what has happened, people are, everybody understands that data is important. It's a game changer. It's transformational and all of that. So people have invested a lot of money in platforms. They have actually hired a lot of data developers. They have bought a lot of these tools, to solve different kinds of problems. So, we have so much data, I cannot discover it. There's a data catalog for that. Okay, now I discovered it, but, the quality has been poor and data is missing and things like that. People have added, quality tools, testing tools, observability tools, data management tools. One thing that is happening because of that is the metadata is just getting split across these tools that don't talk to each other. Okay, quality tool has maybe some GDPR tags and things like that. The catalog tool, quality tool has some quality score and what tests are succeeding and failing. Some observability tool has if the data is fresh or has duplication and missing data and all of that. So in order to understand data today, you have to jump from tool to tool to tool to tool. Okay. Because the metadata is completely fragmented, duplicated, inconsistent. It's almost like, defining location in different microservices differently. You're defining the metadata about data in different tools differently in an inconsistent manner. And people are just frustrated jumping from tool to tool. So that is one thing. And the second thing is, I've actually seen hundreds of metadata systems being implemented, some within the company, some as open source, some as commercial solution. And I believe that time has come where you build a great metadata tool using great schemas and APIs that is extensible and solve the metadata problem so that you can start building all this tooling around it as applications of metadata instead of every tool vertically building the entire stack. You start making these applications make use of already centralized shareable metadata, right? So from that perspective, open metadata has two goals, right? One is standardize metadata so that you have a metadata vocabulary, right? Ontology, so that everybody can make use of this data, this metadata that is stored in a centralized manner, so that they don't have to rebuild this reality again and again and again, repeating the same work, right? The second, so that is build metadata standards, and then build a centralized store that anybody can use, right? So build great APIs so that metadata can be consumed. That is the goal of open metadata, so that metadata becomes a solved problem and we can start innovating around it instead of redoing the same thing that we have been doing for last 2-3 decades.
A couple of things come to mind with that. Firstly, I find it interesting watching some of the very sort of early stage startups building stuff in public and publishing all their data in public and all of their earnings and stuff in public. And I think that's very interesting in terms of how they're doing that. And I've seen tools which look to collate that sort of data and present it in meaningful ways. And it sounds like that sort of tool could sit on top of what OpenMetadata provides. If they were to use OpenMetadata, it would make that approach to doing things all the easier. It's a sort of middleman between all of those different bits of tooling. And the second thing that comes to mind is, when you have the much larger companies and the older companies, that someone keeps buying companies, many companies keep buying companies, as critical bits of system want to get merged, suddenly you've got those metadata silos that you were talking about. And if only your organization had used OpenMetadata to standardize the metadata, your access to that metadata when you're merging becomes immediately easy to do, right? Because you just plug it into the same system rather than different systems. And that's where the standardization really pays off. And those bigger companies can certainly increase their value, I imagine, by standardizing their metadata as part of the offering of merging.
Yeah, and the other key problem is there are all these proprietary metadata systems, and data catalogs. Most important aspect of your data, which is metadata, gets trapped in this proprietary formats, not exportable. You cannot easily replace one tool with another. There's some kind of vendor lock-in for all the knowledge that you have generated that gets trapped in these systems, right? So that exportability, not having vendor lock-in, all of those things are, super important.
Does this play into some of the recent direction of some legislations that are coming in where you have to have data portability? Could the larger SaaS or even the smaller SaaS companies that provide individual verticals of metadata, they're going to have to provide an export feature? Can you assist them in making that more standardized and more usable?
Yeah, actually, metadata is a key part of that solution, but that solution is much deeper. I think JSON schema can play a big role. For example, a user profile, right? My user profile should be exportable from company X to company Y, right? Which means you need standardization of what that profile means. What is the basic set of information that you must have? What are the optional set of information that you have? That way you define a standard schema for what exportability of some kind of data looks like. And so building that kind of schema, I think JSON schema is very important there. So the problem is a lot deeper than just, understanding the data. It's also transforming that data into a standard format so that the other person can actually use that standard format to import it into a different service. I think there is a lot of work that is still required there, but I think JSON schema can be can play a huge role there. In fact, what I think, Ben, is many of these core types, for example, in OpenMetadata, we have built all of these core types, right? Industry-specific types can be standardized, and we can now start hosting those JSON schemas somewhere so that people can automatically pick it up, right? So for example, types like email, types like, say a SQL query and things like that, they have certain constraints, they have certain regex, they have, all of these things can be standardized, and we can start hosting those things so that now you're building a rich vocabulary, right? Using JSON, you're building all these rich types that are industry specific, that is common to, across many different industries. And JSON schema can actually play a huge role in how world represents data and, exchanges data.
Yeah, I mean, there are a number of different schema registry tools that exist today, but none of them really focus on openness. As far as I can tell, most of them focus on, define your own schema registry of stuff that you want to use internally. They don't really talk about openness and publicness. I mean, that's a complete sort of almost the opposite to how Postman works. I mean, Postman has many private APIs that people use, but it's also a lot of the value is in making your APIs public, making them accessible. And a lot of the time people use Postman to make that time to first call quicker for the developers. Sooner the developer can call your API and see the value that it offers, the sooner they're likely to pick it rather than keep looking for other APIs or other solutions to their problem.
Yeah, that makes sense.
Just circling back to when you were building OpenMetadata at the beginning, what was that kind of light bulb moment for you in terms of discovering JSON schema to be the right solution? When did you decide, okay, this is the one that we're going to use now?
So many people who build systems, right, they end up building some kind of an implementation and throwing that implementation over an API, right? Where whatever is your implementation detail ends up becoming schema, right, of types and entities that make that are part of your API. Our approach was, we wanted to take schema first approach. If this data is really important, design this data well. And then, we chose JSON schema, as I was telling you. And then, once we have JSON schemas, we needed to provide them over APIs. And, we were building our API server using Jetty, Java frameworks, Drop Wizard, and all of that. And so we ended up using, huge call out to JSON schema to Pojo tool. We use that to take schemas and turn them into Java code. Okay, that was so smooth. Many hours of boilerplate coding and just hand editing things and keeping it consistent with schema was eliminated for us, right? So we just started generating Java code, and then we built an ingestion framework. So we have a Python-based ingestion framework that connects to different metadata sources like databases, tables, dashboards, services, and it ingests the metadata. And the first implementation that we did was, we were hand coding a lot of things in Python, right, for the JSON schema compatibility, where we are hand coding and filling the fields and all of that. And then we bumped into Pydantic, and we started generating even Python classes based on this JSON schema using Pydantic. Whole bunch of errors, inconsistencies, keeping up to date, eliminated, right? Exactly like Java. Then we took it to the entire next gear, right? So we have UI that is built using JavaScript framework. We started generating TypeScript classes using JSON schema. Okay, then we started generating our forms based on the constraints expressed in JSON schema. What is required, what is not required, what is the validation for the field, right? The regex, everything was done on the UI itself. Now imagine, all we are doing is, we are putting the thought into what should be the schema, what should be the constraints, what should be the structure, what should be the vocabulary, what is the description. It translated into across all our code base. Code got generated. They were always in sync. No runtime errors, no hand validation, no even API documentation. You don't have to document saying this API contract is this and we expect this. All of those things generated from this seed that we have called JSON schema. fully blossomed into every part, right? So
Wow.
started from, keeping all the implementation, code generated, API documentation. Validation is done just using JSON schema constraints, both on the server and client side. Anybody can validate their data independently. And then it started getting even deeper. So we started using, we started building with MySQL and Postgres, and they have JSON column type now that they support as a first-class type. And we started storing JSON documents that are compliant with the JSON schema that we have defined. And then JSON columns are so powerful, you can actually take the fields, extract them, and store it as generated columns. So essentially, you're storing just document, but then you're also generating all these columns out of this document that can be indexed. You can build constraints, all of those things. Right? And then, so all our code is generated from JSON schema. Our data is stored using JSON schema, right? And validation, forms, all of those things are from JSON schema.
Wow.
And then finally, API and documentation is JSON schema. So you can actually see so much work eliminated, and everything is consistent.
Yeah, I mean, it's like, doing all that work at the beginning, doing Schema First, it's like a huge shift left in terms of what you're actually having to do and eliminating so much work, as you're saying. That's really impressive that you managed to use JSON schema at all the levels of your stack. Yeah, I mean, I'd love to see some of that code someday and see how that's working, because that's frankly pretty impressive.
Yeah, no, I every time I'm presenting OpenMetadata, I tell all the developers, JSON schema is a powerful tool that everyone must have there in their toolkit, right? So in fact, our configuration itself is JSON schema compliant. You're not, we can see if the configuration is valid or not through all these constraints, instead of, trying to debug, hand debug and all of that. So there's whole level of validation that happens so that we only focus on real problems, right? Not just, this format is not right, something is missing here, that kind of stuff.
I mean, how many security problems over the last couple of years have been through misconfiguration?
Correct.
And it's user error that can be eliminated.
Correct. And debugging, right? Somebody says this is not working, and then you go debug, you have to print the configuration, and then you figure out that this configuration value is wrong. Everything is validated through JSON schema.
Yeah, I mean, I had a very similar problem only yesterday. Some quite popular code was expecting a particular header to always be a string, and it happened to be a Boolean, and it just crashed and it wouldn't build. But it's, validation really matters, particularly when you're able to use it in so much of your stack. That's really impressive.
And not human beings hand validating it, right? It should be captured in one place and consistent everywhere. Otherwise, this is, this module is checking 3 conditions, the other module is, the inconsistency should go away. I think people should not be hand validating, right? You should be using a schema to validate everything, right? As much as possible.
So you mentioned earlier when we were discussing JSON schema and how you're using it within OpenMetadata, you're saying you're seeing other similar initiatives sort of follow your lead on that in terms of using JSON schema. Could you sort of expand on that a little? Tell me what you're seeing in that space.
Yeah, we've seen cases where people had built, the decision that I would have made if I had not bumped into JSON schema. People building their own schema languages, schema validation, and all of those things, right? So there are, open source projects that I've seen that have used proprietary schema modeling languages. Now, after we started showing how JSON schema is powerful, those, projects have started adopting JSON schema. So they're sort of like half on some proprietary schema language, and now they're migrating to JSON schema. The second thing that is happening is because we are trying to define metadata standards with clear vocabulary, type system, and all of those things, many people, many data tools in the ecosystem now understand the power of JSON schema. They're not only adopting JSON schema for themselves. In fact, many people want to adopt our schema definition, schema modeling. So this is where, we'll continue to work with many different tools and platforms in the data ecosystem so that we can actually take that part of metadata specification part and make it a specification that anybody can use, adopt, extend, right, as a community. continue to build core vocabulary for data, right? So there's a lot of JSON schema adoption that is going on. People have been using JSON, right? But many people are using this JSON where they're just showing some example JSON blob and all of those things. Once you make it schema, everything is clear. All constraints are there, descriptions are there. You can do validation, all kinds of stuff.
Yeah, you stop having to make those assumptions as well. Miscommunicating things. I mean, that's disastrous.
Correct.
Well, thank you so much for joining us today, Suresh. That's been so exciting and interesting. I'm really thrilled to hear you're making such good use of JSON Schema. So thank you so much for sharing that with us today.
Yeah, and I think thank you for the JSON Schema community for coming up with this specification and coordinating with many different moving pieces and helping us, people like us who are JSON Schema users. Few shout outs for even JSON schema based tools. JSON schema tools are very rich, very diverse. You want to do something, there is a tool for that already. Especially I want to call out JSON schema to Pojo community for fantastic Java code generation from JSON schema. And then Pydantic community for Python code generation, React JSON schema form documentation. They generate automatically forms that you can actually gets validated, right? So the validation starts at schema design, goes all the way to API, UI, all kinds of things, right? And then excellent support for JSON from MySQL and Postgres. Hopefully they also become JSON schema aware, not just store JSON. That would be fantastic, right? Everything then gets compliant with one schema definition. So yeah, just want to call out those communities.
Yeah, I mean, JSON schema wouldn't be so ubiquitous as it is without all of those communities working so hard. So yeah, definitely thank you so much for pointing all them out, and thank you.
And one last call out is OpenAPI 3.1, guys. I think they've done a fantastic decision of adopting JSON schema compatibility. I think this is huge for the industry, and we are looking forward to some other development to complete so that we can just go to OpenAPI 3.1. Now, a lot of, hundreds of lines of this Swagger annotation, Java code can be eliminated. And, we are now even more centered around the JSON schemas, right? That defines the metadata standards. So looking forward to that.
Definitely. Again, thank you so much for joining us today. And I look forward to our continued discussions. So thank you so much, and enjoy the rest of your day.
Thank you, Ben.